Good morning, my dear students. So, coming to the last part C in computer aided modeling analysis lab. Okay, so in part A we studied what theoretical problems and how to solve problems in ANSYS method. Okay, so in ANSYS software, and also part B also we studied. Okay, in part A what we studied related to beam and bars and trusses problem. Okay, so that is simply supported beam with point load, simply supported beam with the what uniform distributed load, varying load, same like cantilever beam also. Okay, so cantilever beam with point load, uniform distributed load and varying load. Okay, and second part is related to bar. Okay, so how to solve problems by using ANSYS method, that is a single bar, stepped bar problems. Okay, and coming to the third section is what related to trusses problem. Okay, so how to solve trusses problem in ANSYS method. Okay, so if you solve by theoretically take more time, by using with the help of ANSYS we are going to get very quick answer. Okay, that is very it will consume very it will what we are going to save the time by solving the ANSYS method. Okay, so coming to the part B, again in part B we studied about what that is related to plate with a circular plate. Okay, so that okay, plate with circular plate is comes under in part A. Okay, in part B we what we studied related to, that is a heat problem, that is a dynamic analysis problem and vibration analysis problem. Okay, coming to the part C, so this is not for what you need not to practice in ANSYS method, is only for the demo purpose. Okay, so part C you have to understand just so what you mean by graphic standard. Okay, what method we are going to use to solve with help of this software. Okay, so coming to the second part is what here they are taking one example for, that is what the contact analysis problem. Okay, how what is a contact analysis problem and how to solve, that is a how to that is contact analysis, nothing but two metal will be bonded to each other. Okay, so how the stresses and deformation which takes place, that problem how to solve, that we need to understand. And coming to the last part is so demonstrate the at least two different types of example for the model and analysis for the bars and plate made with a composite material. Okay, so already we studied. Okay, so this bar problem. Okay, so bar nothing but what so each node having the only single degree of freedom, but whereas in the composite. Okay, so along with that composite material nothing but what the material which is made up of more than two material. Okay, so this I think you understand. Okay, so after studying, after practicing the two part A and part B, this is what we solve this type of the problems. Okay, problem related to what the bar and composite material. Now let me see what is the definition of these two, that is a contact analysis and graphic standard, or IGES and the steps. Okay, so these are the software how to solve what with the help of the graphic standard, there is a contact analysis problems and the any problem with the help of what this graphic standard. Okay, so coming first, let me understand the part B, that is a B1. What do you mean by contact analysis? Okay, so contact analysis is nothing but what it is a find to contact analysis is to find the contact point and the contact force. Okay, so if you consider two material, means where the contact point will be there and where the contact force is going to act on that particular material. Okay, so including the contact pressure and the frictional force is called as contact analysis. Okay, so in finite element analysis, instead of this contact point and contact force, we are going to consider what as the displacement and the forces. Okay, so how what are the causes, what is the deformation takes place between the two material and how the force is acting between the two material, that is the we are going to call as a boundary condition. Okay, so whether in the constant material, when we are going to fix the material, when we are going to fix at what node, that we need to consider here. Okay, so in finite element analysis, either displacement or forces is known as the boundary condition, and the another the variable is solved through a equilibrium requirement. Okay, so remaining quantity, that is the stresses sustain, and we are going to apply the equilibrium condition, then you need to find okay, so that's about the contact analysis. Okay, so contact is the boundary non-linearity. Okay, so contact it is like a boundary condition. Okay, the graph of the contact forces versus the displacement become the vertical. Okay, if you consider any two body, the forces and the displacement, that will become the vertical. Okay, the both the displacement and the contact force are unknown, is in the interface. Okay, so this displacement and the contact force will be there in between the two material, it will be present in the two material. Okay, that is called as the interface. Okay, so what are the main objective of the contact analysis? Okay, so there are four objective of the contact analysis. Okay, so first one is whether two or more bodies are in contact. Okay, let me first check whether the two bodies are contacts are there or not. Okay, so first you have to check that whether the location or region of the contact is applicable, contact is there or not. Okay, so here one sentence is missing, that you have to note down. Okay, and the third one is how much contact force or pressure occurs in the interface. Okay, so after applying the forces or after working on that two material, so how much force is acting, that you need to consider. Okay, if there is a relative motion after contact in the interface. Okay, so after some doing work, there is a relative motion is there or not, we have to check that. Okay, so these are the these are the four main objectives for this contact analysis. Okay, so what is the procedure for in answer contact problem in FEM. Okay, there are two procedure we have to apply. So first one is find whether the material point in the boundary of the body is contact with the other body. Okay, so let me first, you have to check what the two bodies are contact with each other. Okay, so if it is there, means you can go for solving the problem, otherwise it is cannot. Okay, it cannot. Okay, so coming to the second one, if it is in contact, then corresponding contact force must be calculated. Okay, so with the help of this the software. Okay, so once if you two materials are bonded to each other, then you can go for calculating the deformation, stresses, strain for present in that particular material. Okay, so this is about the contact analysis. Okay, so coming to the composite wall, I already told you in model number 4 theory class. Okay, composite wall or composite material. Okay, heat due to conduction, convection, radiance, all those things. Okay, composite wall, nothing but what, the material which is made up of more than two material. Okay, so that is called as what, composite wall. Okay, so it is a wall built up of a combination of two or more Mansouri units of different types of material that are bonded together is called as what, the composite wall. Okay, and forming a and one forming the facing of the wall and the other wall is backup. Okay, so it is related to close one. Okay, so both the materials are contact with each other, that is called as what, composite wall. Okay, so what is the composite wall in heat transfer? Okay, so here in a heat transfer, we are going to transfer the three way of heat conduction from one material to another material. Okay, so already we studied that is conduction, convection and radiation. Okay, so composite wall compares of number of layers of a different material with a different properties and thickness. Okay, such cases include the number of series or parallel thermal resistance arising from the different layers of the material. Okay, so these are the different material which is made up of the material which is made up of different material, different properties, different thickness. Okay, coming to the third, what is meant by the composite wall and give its application. Same, this is what the composite wall material is a new generation of high performance bond, that is a building internal partition produced by the industrialization. Okay, and it is composed of variety of the buildings material and replacement traditional bricks. Okay, so here we are with the help of this, the application is we are going to transfer the heat from one place to another place, and the composite walls are used nowadays everywhere, that is especially in the industrial sector. Okay, so these are the some of the brief the note on this composite wall. Okay, so coming to the second, that is what you have to study the bar also. Okay, already we solved the bar problems in the theory class. Okay, so that is a bar, nothing but what, the axial force. Okay, so in FEA these members are modeled using a bar element. Okay, the bar elements are one dimensional line element that can take only the one compression or one tension forces. Okay, so here if you draw one line, means that is each node having only one displacement or 1 degree of freedom, that is called as bar element. Okay, so here either force can be either tensile or compression. Okay, so this is what related to bar. And what is the bar in FEM? Okay, so it is composed of the two different parts also. Okay, so not only the line or the element which is made up of more than two material or three material. Okay, and it is composed of two different material or parts. Okay, one steel tapered or uniform aluminum part. Okay, so here calculate, so one material may be a aluminum, one may be a steel. Okay, so by with the help of that, we are going to calculate the displacement. Okay, and the trusses. Okay, so we are going to calculate the displacement field in particular to that element. Okay, and FEM, that is a bar and trusses for these are the two example for this related to FEM. Okay, and the bar may be represented by two element. Okay, so here bar element cannot be there in a single point. Okay, it can be defined by two nodes or 2 points. Okay, so best example for this bar and trusses. Okay, so coming to the first that is a A1, that is what you mean by FEM, what is the computer graphics in FEM. Okay, so look at this, these are the two we are going to use the IGES or the step. Okay, so in next slide we will study these two. Okay, so finite element methods are commonly used to animate the elastic bodies in computer graphics. Okay, so this is like a software, like same like in ANSYS. Okay, these methods are particularly well suited to elastic deformation because they are compute an explicit deformation function, thereby allowing them to reverse deformation exactly. Okay, so here the problem which is consist of what, the elastic deformation. Okay, that can be solved by using this computer graphics method. Okay, so look at this is a one CAD model will be there here, that will be sending to the preprocessor. Here they will work, here again preprocessor will model come out, or here product will become. Okay, so like that you have to process will be there. Okay, so here mistake, here the cut portion will be there. So this is a preprocessor. Before that a model will be there, that is a CAD model. Okay, so what do you mean by this IGES? Okay, so IGES nothing but it stands for the international, that is original initial. Okay, so international graphics exchange standard, and a neutral data format that allows the digital exchange of an information among the CAD system. Okay, so this is the definition of IGES. Okay, the initial graphics exchange specification, that is IGES shortly, is in a vendor neutral file format that allows the digital exchange of information among the computer aided design, that is a CAD system. Okay, look at this here, the IGES nothing but what, so here the it will allow the digital exchange, information takes place. Okay, finally you are going to get the CAD model. Okay, the CAD system will get the product. Okay, so second one is the step. Okay, so here it is adopted, second one is the step. Yeah, okay, so it is adapted from the official title, that is official title of, it is approved by ISO, that is 10303, and it is a ISO standard for the computer interpretable and exchange of the industrial product data, and referred as a standard for the exchange of product model data. Okay, so this is another name, this is both are same only, that is a step and IGES. Okay, the development of step is an undertaking continues after the development of IGES. Okay, so this is the updated version. Okay, in other words, the emphasis was to eliminate the need of engineering drawing and the other paper documents in passing information about the different product phases being the performed on the similar or dissimilar CAD CAM or CAE system engineering. Okay, so this one I step just to understand that this step nothing but what, it is a modify of IGS. Okay, so here we are with the help of what the CAD model. Okay, finally we are going to get the product in the okay, for the very fine values. Okay, so these are some of the advantages for the IGS. Okay, so it will store driving the information in an ASC double or binary neutral format, which can then be exchanged between the various user. Okay, so this is the main first advantage. Second one is IGS originally supported drawing and wireframe, and was later extended to the support surface and the solid. Okay, so here it can be the exchange between the various user. Okay, so first it will filter CAD model first will be there, and second it will filter, and third will be filter, then you are going to process according to that process, that is input, we are going to get the model. Okay, so the main disadvantage for this IGS nothing but it does not have any formal information model. Okay, so exactly informal data it can be what we are going to model. Okay, so coming to the that is the advantage of the second one, that is a step, that is a modify of that IGS. Okay, it allows the viewing and modification of geometry using any CAD tool capable of interpreting step geometry and break up the dependency between the CAD system and the product definition. Okay, so here in this step we are, wherever we are going to modify, that we can modify in between the model. Okay, so that is the first advantage, whereas in the IGS it is not possible. Okay, so very useful for grouping mechanics element in a certain view. Okay, and third one is included in the assembly schematic containing all the connector entity. Okay, so we are going to connect each element at particular convenient. Okay, so fourth one is easy for derivation for the implicit information content. Okay, wherever you need to calculate the values you can calculate. And the main disadvantage for this step is, so high costing and skill are needed to standard exchange. Okay, so labor cost is required and a person is required to exchange the data, that is a standard data. Okay, so this is what the brief introduction about this part C related to what the Kama lab, that is a computer aided modeling analysis lab. Okay, so so look at this part A just related to, these are the software, the IGS, so graphics which will be there. Okay, but for your syllabus, just to study the theory, what do you mean by graphical standards. So this is look like a ANSYS software. With the help of this software we can modify better than the ANSYS software. Okay, so already this we studied about what the contact analysis problems, how to solve the contact analysis problem with the help of these two or any analysis problem. Okay, so here we are going to calculate the contact displacement and contact force acting between the 2 points, and this already we studied, that is what the related to bar and related to the composite material problem. Okay, so I hope you understand this part C. Okay, so here nothing will they ask in examination, just to understand the what is the content part C. Okay, so I hope you understand this. Okay, thank you.